Whoa, Kevin Cole back at you at Super Micro. So today we're going to continue our series of podcasts on lifecycle management, managing Ampere-based servers in our evaluation lab. So when you start to think about basically lifecycle management from an enterprise, there is basically a flow or tasks that are associated with certain individuals that are performing these tasks and defining those guardrails against security for role-based access control becomes very, very important. So a server architect will have various tasks that they perform operationally in the data center. Um, the network administrator has tasks that they perform operationally in a data center, so on and so forth. So before we get started in logging into the platform and navigating through the web GUI for SuperCloud Composer, um, you want to begin your day zero lifecycle management. And that day zero lifecycle management, a Ampere server shows up at your door at customer site and it's packaged in shrink wrap. And you want to be able to quickly deploy that system, define a software defined data center presence within your data center, organizing your data center so it's easy for you to manage these Ampere servers. So you're going to see here later on how we're going to create a group or a pod of Ampere-based servers. We'll call that an Ampere farm. And then we'll also delineate 2U servers from 1U servers based on Ampere servers and how both of those particular racks will be combined and be associated with an Ampere farm. And so you can do this based on applications too as well, defining a VMware farm, defining a GPU tenant cloud, so on and so forth, right? So this is important that you logically represent your data center, organize it in a way that becomes very easy for you to manage as a DevOps administrator. So that also talks about defining IP address ranges and making sure that those IP ranges are contiguous in nature, right? And being able to easily device discover a range of IP addresses through a ping spray. So that becomes very important. Defining the rack slot unit locations physically that are going to be mounted in your racks too as well becomes important, and identifying them and documenting them based on perhaps a backup spreadsheet. So doing the front end work first, right, before you start getting into logically representing, creating racks, creating pods, and then at this point, defining them within your data center. So if you don't do any of these pre-steps to organizing your data center, it becomes a mess. And it's going to be very difficult for you to get oversight holistically which particular server is in which particular rack slot unit. So this is very, very key of having an organization or having some type of methodology that you can easily deploy servers, quickly get them up and operational, and then also with organization, be able to quickly identify those servers that have been impacted based on an outage, make the necessary mitigation to fix those servers and bring them back into your data center. So remember, servers that are down and have been impacted by an outage, whether it be a component failure or any other type of impact, uh, is going to cost you money, right? And quickly bringing those servers back up so you can define applications to run on there and be efficient within your data center to be competitive against competitors that you perhaps are selling widgets within your environment, right? Is selling a product, right? Which is basically operational running applications for business enterprise, or perhaps doing LLM models that are confined within your data center. So these are all important things that you need to really think about before you really jump in and basically start creating a pod, creating racks, associating those racks with pods, and so on and so forth, right? So we're going to jump into our evaluation lab. Because we're not defining IP addresses in contiguous space, because we have a plethora of different servers coming in for validation, We're just going to basically use IP addresses to device discover those. But realistically, in a real world, you want to have contiguous space. Likely those servers, once they get deployed through day zero operation, they'll be pretty much static in nature. Because of the dynamic nature of servers coming in and out of our data center for evaluation, it's very difficult for us to maintain contiguous space, right? So this is important, right? In a real data center where you have things defined, and typically those are static in nature, you want to define IP address scopes within a contiguous IP address space, so it makes it easy for you to perform device discovery for day zero operation. All right, so I kind of rambled on that, associated with really talking about the importance of organizing your data center. Next, we're going to do is we're going to log in to our evaluation platform. And there are, like I said, two ways that we log in. This is nothing different than if we were performing lifecycle management on an AMD platform, or whether we were doing it with a Grace Hopper platform, or perhaps an Intel Gaudi Habana system, right? The key here is Supermicro is driving the industry and market leadership of creating a platform that is open standards based, that will support any type of semiconductor vendor in the industry. And that's what's important specifically for your use cases within your open enterprise management solution for your enterprise. So let's log into the platform. The first thing we're going to do is change the domain. There are really a couple of ways to log into the platform. If you're using Keycloak open standards base for single sign-on, you can typically come in through an LDAP domain. We provide that capability for you to come in and log in. But in this case, we're going to use Microsoft's Active Directory service that exists within your enterprise, and then log in there using COP-K, which has been assigned through global admin. So let's log into the Active Directory domain. So we have a Microsoft server that is basically providing a service for Active Directory, and we're going to log in there. Okay, so we're going to plug in our role-based access control user account that's directly attached or integrated with Microsoft Active Directory services, and then we're going to plug in our password. And once we come in, a couple of things I want to go ahead and point out here. So everybody gets logged in operationally to the dashboard, which is really 10,000 or 20,000 foot view of your data center. It's broken down into various different quadrants. We're not going to get into the specifics of that because there are previous videos that I've talked about of navigating through the different technology buckets that exist within this dashboard. So again, nothing changes, right, in regards to whether you're managing Ampere servers or AMD or Intel-based servers. It's all the same, right, in the way that we provide the look and feel of unification of our dashboard. And that's very important for DevOps administrators in their data center, because they may have different semiconductor processors that they need to manage, and they want to manage it from one unified dashboard. They don't want disparate tools to manage Ampere servers and basically AMD and so on and so forth, right? It's going to be important for them to provide one central location that they can easily make those data-driven decisions and provide at scale the ability to configure, manage, monitor, alert those types of server platforms in their data center. So on the right-hand side, I want to just point out a couple of things here. So the first thing is, how do we log in, right? We want to define what is our particular environment or our profile, right? And so that's easily defined by looking at the profile section here. And you can see here, my role is super admin. Okay, so I'm basically global admin that is has high credentials, right? That I could basically perform anything within my data center, right? That has to do with those ability to create a rack, associate servers with a rack, perform lifecycle management. So I have all the various different roles, the capability for looking at network administrator information, metadata, looking at server information, looking at BIOS, excuse me, being able to deploy any of those use cases for each of those particular roles is going to be extremely important. All right. So we define the role. So we're ideally coming in as super admin. And the next thing we want to look at here in the icon is the ability for you easily to navigate through the platform to look at various information here that you want to perform regards to maybe there's something you don't even know how to do, right? Maybe you want to be able to understand about how do I navigate around PODview, right? So we provide all the various different documentation online that you can easily index and search to get an idea of what type of task that maybe perhaps you're not really knowing how to perform, right? And so we work very hard to provide this within the online help for you to be easily able to look up quickly without having to thumb through reams and reams of paper of documentation. Of course, if you want to do that, we have the ability to print that out if you want, but we provide it online for you to easily navigate through and determine what type of tasks you want to perform and get an idea how to perform those tasks. So this is all available online help by clicking on, again, the icon, which is basically SCC Support Center. So you can easily navigate here. And we noticed we've actually launched a new particular browser session instead of having to navigate around. So we make it easy for you to navigate through the platform here and be able to see what you need to do. Of course, you can download any of this associated with SuperCloud Composer by coming up into this area, which is the Welcome Center area, and then downloading any of these, which can be downloaded in PDF format or can be basically printed out. Okay, so that gives you an idea of how you're going to navigate around SuperCloud Composer to get an idea of how you're going to manage any server, right? But in this case, our use case is focused on Ampere servers being able to perform lifecycle management. So the next thing we want to do is through day zero operation, we want to logically represent or organize your data center effectively and efficiently within a software defined data center. And that becomes very, very important for you again to streamline and optimize your operation. So it's easy for you to identify servers or identify where those servers are physically located within racks or they're part of a pod or a group. So the first thing we're going to do here is come into PODview, and we want to create, as I mentioned before, a group of Ampere servers that are scaled across multiple racks. And so the first thing we do is on the right-hand side, we come into edit mode and we want to create. The first thing we want to create is a pod. And that pod we're going to label as Ampere Farm. Okay. And if you had the opportunity or flexibility, you want to create additional ones, we can add them in here for other groups. But in this case, we're just going to create one Ampere farm that is a pod in which we're going to have two racks that are associated with that pod or that group. So the first thing is we create this, and then you notice on the left-hand side here within the tree view, we have a Ampere farm that we've created, which is a group. Now, we don't have any racks associated with it or supercluster or in-row CDU associated with it because we just created it right now, right? So we have to associate those racks for the group or the pod. So the next thing we want to do, and you can see here by collapsing and uncollapsing, we can do so. But again, there's no racks that are associated with this pod itself. So the next thing we want to do is we want to create now a rack. And the first rack is we're going to label it as 2U Ampere servers. So this is any description you can put in here um, to create a rack. And the other thing is you might want to say Ampere, and we're going to say building, I don't know, building 6, let's say, right? And we want to give it a location of, let's say, for example, Phoenix, right? And that's where the location is, right, of where those racks are. And it's in building 6. And we want to, let's do something a little different. Let's call it building 6 and then Phoenix. And then what we can do is give the rack description of 2U, and we want to give it Ampere servers, right? Because maybe we have in building 6 other semiconductor platforms out there, right? Like Intel or NVIDIA Grace Hopper or Blackwell chipsets or that kind of thing, right? So we want to just give it building 6 Phoenix is where the data center is. And let's change this to data center to make it a little bit more descriptive. Um, so let's see, data center. Okay. And notice I'm Canadian, but now I'm an American. I spelled center with the British spelling RE, but you could call it ER too as well. So it's not incorrectly spelled, right? Little joke there. So anyways, rack description, we want to place it in 2U Ampere server. And what's the size of our rack? We could basically put it as a 12, 20U, 42, 48, 52, or 58. 58U size racks are large. I just use a step ladder to get up. Hopefully, you're not taking two people and walking up the rack with a step ladder. Hopefully, you have one of those high performance lift server racks that you could easily mount within your rack, right? I can imagine in the old days when we didn't have those that we were carrying up basically racks up a step ladder, which is obviously very dangerous, right? So these rack lifts now that they have, because the servers are getting very, very heavy, especially when you're talking about GPU servers, you really need one of these rack lifters within your data center to help you mount these within your rack. So in our case, we're going to use it as default. And you noticed here that we created, basically it creates it automatically in the default pod. But because we created the pod now, we want to now associate that rack, that Ampere server rack of 2U servers, to the Ampere farm, right? And then we can also change the raw location if we wanted. In this case, this really talks about if we were associating it with an in-row CDU. So this use case doesn't apply. This is usually when we're dealing with liquid-cooled racks that we have an in-row CDU we want to associate for the rack location. So we leave that as unassigned, and we are not going to save it because the next thing we're going to do is create another rack, okay, and associate it with the Ampere farm too as well. So that's going to be in location building 6 again within the Phoenix data center. Let's just cut paste here. It's going to be easier than me typing and watching me type. And then here, you notice here, it's giving us basically an error here because we spelled center wrong, right? But really, it's not spelled incorrectly here. It just depends on what side of the globe you're on. Okay, so we want to basically say this is, let's change this to say building 6A, let's say here, because maybe we're in a different floor. Let's change that here. Okay, and we only have an amount of space here, so we're going to say DC here. We're going to kind of, okay, and then we'll come up here and we'll call it, I'm going to call that, let's say F1 for floor 1. Floor 1, and let's call this floor 2 down here. All right, and we want to create 1U servers. Now notice each of these are required in order for you to, like where the asterisk is of red, is a required field that you have to actually fill in or associate with. So we're going to say 1U Ampere server. And then we're going to remember, if we don't associate it with the Ampere farm, that rack is not going to be associated with it. And now we're going to save it, right? And then we have success that we've created this. And you notice here now the racks are 2 as part of the Ampere farm. And if we click here, we see both racks, which are unpopulated, right? They're unpopulated because we haven't associated any servers yet for each of those racks. So now we have 2 racks, which are in building 6, floor 1 and floor 2, that are associated with the Ampere farm that we've logically represented within our data center, our software-defined data center. And if you want to go in here and you make changes and typos, or you want to change things, you can ideally come in here and make those changes or delete them if you need. So we have all that capability here within SuperCloud Composer to make edit and delete and additions and changes to your environment. Okay, so now we're back into view mode, right? So you noticed here, edit mode. If we want to return back to view mode, we just click here. So the next thing that we do here, and I want to just point out here too as well on the left-hand side, that these represent a hierarchy in which we provide the Ampere farm itself. So you can see here both of these showing up, and we provide rack information. There's no PDU information here, and we have it for both floor 1 and floor 2. So the next thing we want to do is we want to associate a PDU and associate those servers through device discovery within each of these racks, right? So because of the time, I want to kind of minimize these vignettes. So we're going to create another video to show you how you take devices or servers and associate it with each rack, and how you add a PDU within that rack. So we'll see you next time. Thanks for joining. Have a great day.